So today we're going to get into where you would really use synthetic division normally. And that is, I need to find all of the zeros of this function. Now some of them will be rational possibly. In this case I will guarantee that there are two rational zeros. If this is an x to the fourth, my final answer is there are four different zeros to this. They might be rational, they might be irrational, they might be complex and imaginary. Complex and imaginary roots always go in pairs. So if there's an x to the fourth, there's either going to be no complex and imaginary roots, 2, or 4. I will guarantee you with the ones you're giving right now, you will have two rational roots on an x to the fourth, because it's got to be something that you can get it down to an x squared. So how do I even know? They told me 1/3 is a root. How would I even know to even try 1/3 in this if they didn't give it to me? What you're going to do to find all of the possible rational roots of a polynomial, take the factors of the constant. So the factors of positive 6 are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6, and make ratios of those with the factors of the leading coefficient, which is 3, so positive and negative 1, and positive and negative 3. Put each of these over each of these. So positive and negative 1, positive and negative 1/3, going to 2, positive and negative 2, positive and negative 2/3, 3, positive and negative 3, 3/3 is 1, we've already done that. 6, positive and negative 6, 6/3 is 2, we've already done that. Somewhere in these 2, 4, 6, 8, 10, 12 numbers are two rational zeros. Now, there could be a double zero. So like we know 1/3 is 0 because they told us 1/3 could be a 0 again. But somewhere, at least two of these, maybe four of those, but at least two of these are rational or zeros of this function. So I'm going to take the 1/3 they gave me and do synthetic division with that 1/3 because they told me it's a 0 already, and the polynomial they gave me. There are no missing terms, so I don't have to put 0 anywhere. 3 down multiplied by 1/3, add that together, multiply by 1/3, add that together, multiply by 1/3, add that together, multiply by 1/3, add that together. It had better be 0 because they told me this was a 0 of the function, so I shouldn't have any remainders. Now what this really is, and we're not going to use this unless you're punching things in your calculator, this is really 3x cubed now plus 3x squared minus 15x minus 18. I'm writing it a different color because we're not going to use it directly, except I need to find another one of these numbers that would be a 0 of this function. One way to do it is to take this and put it in my calculator and replace x with 1 and then negative 1 and 1/3 and negative 1/3 until I find the right combination to give me 0. The other one is just to use synthetic division and erase all that. I tend to start with my integers. So 1, 3 down, bring the 3 up, 6 times 1, negative 9 times 1, yeah, that's not going to give me 0 at the end. So then I erase. Again, erasing is going to be happening a lot on these. And after I erase, I'm going to try negative 1. So 3 and negative 3, 0, 0, negative 15, yeah, that's not going to work either. And then again, I tend to go with my integers first, and if they don't work, then I go back and I work with my fractions. So I'm going to go to 2, 3, 6, 9, 18, 3, yep, that's not going to work. I'm going to try negative 2. 3, negative 6, that would make this 3, and make this, and I really should erase and make this neat. So that would be negative 3 times negative 2, add those together, times negative 2. Hey, we just found our other 0. So this crosses, if I graph this, it crosses the x-axis at positive 1/3 and at negative 2. At this point, I abandon synthetic division because this is really 3x squared minus 3x minus 9. And as soon as it's down to a quadratic, I can use the quadratic formula or factoring or completing the square depending on what will work. I want to find when it's equal to 0. Since everything here is divisible by 3, the first thing I would do is divide everything by 3. So I'd have x squared minus 1x minus 3, minus 1. No, minus 3 equals 0. That's not factorable, so I'm going to use the quadratic formula. x equals 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 3 all over 2 times 1. This is like 1 plus 12, so that's the square root of 13. So I end up with x equals 1 plus or minus the square root of 13 over 2. I can't reduce that. So my final answer, my actual zeros, ooh, that did not go well. My actual zeros, these are all the things that might have worked. The ones that really did work were negative 2, 1 minus the square root of 13 over 2, 1/3, and 1 plus the square root of 13 over 2. You need to list those 4 zeros out separately. Now I'm going to cheat a little bit on the second one. My possible rational zeros, first of all, for negative 110, I'm going to go out and list those. Positive and negative 1 times positive and negative 110 would be factor pairs. Positive and negative 2 times positive and negative 55. 3 won't go in evenly. 4 won't. 5 will. Positive and negative 5 times positive and negative 22. 6 won't. 7 won't. 8 won't. 9 won't. 10 won't. Positive and negative 10 will, sorry, times positive and negative 11. Those are all my factor pairs of negative 110. Luckily, this is just positive and negative 1. So my possible rational zeros in this case are actually those numbers. They told me that negative 2 is a 0. So I've got 1x to the 4th, negative 6x cubed, 10x squared, negative 3x, and negative 110. No missing terms, so I don't have to put a 0 placeholder. Bring it down, multiply it by negative 2, combine it, multiply it by negative 2, combine them, multiply it by negative 2, so negative 52, combine them, multiply it by negative 2, and again, this had better be 0 because they told me it was. I'm going to cheat this time. I would have started, and I did when I did this, start with positive and negative 1, positive and negative 2, and then, excuse me, positive and negative 5, and I believe, if I remember correctly, 5 works. It's either 5 or negative 5. So bring down the 1, multiply by 5, combine those, multiply by 5, combine those, multiply by 5, and that's my 0. And I'm just cheating right now for the sake of the fact that this video is very long. So now I'm left with x squared minus 3x plus 11, and I want to set that equal to 0 and solve. So x equals 3 plus or minus the square root of 3 squared minus 4 times 1 times 11 all over 2 times 1. And I say all over, so the fraction part needs to go out here. This would end up being 9 minus 44, so that's the square root of negative 35. So I have x equals 3 plus or minus I times the square root of 35, which I can't simplify anymore, over 2. I can't reduce this fraction, so my actual final answer, the zeros when I found them were negative 2, positive 5. I usually list my real ones first. And then 3 minus I times the square root of 35, and yes, I expect you to list these out separately, over 2. And 3 plus I times the square root of 35 over 2. Now what I know about this function, it's an x to the 4th, so it looks kind of like a W. It opens up. It crosses the x-axis at negative 2 and positive 5. It doesn't cross the x-axis again because those are imaginary zeros. This one opens up, x to the 4th looks kind of like a W, and crosses the x-axis in these 4 different places. 2 of them are rational. One of them is rational. 2 of them are rational and 2 of them are irrational, but they're all real numbers, so it does cross the x-axis in 4 different